For vertical asymptote, if I were to find that kind of like in 8.2, for vertical asymptote, you set the denominator equal to 0. And then that causes your domain to be negative infinity to your vertical asymptote, union, vertical asymptote to positive infinity. And so that is kind of the rule for domain, if you recall from last time. For horizontal asymptote, that one is a little bit more complicated. So you have to look at the degree. So look at degree of top and bottom. So the numerator and the denominator. If that's a union, so that just means like it's like a connector kind of, because your denominator is going to have two of them. Yes. So if you look at the degree of the top and the bottom, if your top degree is bigger, then what? Then you have no horizontal asymptote, right? You have no horizontal asymptote if your top is bigger.
So like the top thing that you do actually set to 0.
So like if you had x squared over x. So if your top degree is bigger than your bottom degree, then you would have no horizontal asymptote. If they are the same, then what do? It's just the coefficient in front. So if you had like x over x, or x squared over x squared, then it is the coefficient or the number in front. So the x's would cancel. Like if you had 3x over x, then the x's would cancel and your horizontal asymptote would be y equals 3. It'd be 3 over 2. And then if the bottom is bigger, so if bottom degree is bigger, then it is y equals 0. So if you had x over x squared or something like that, then it's just 0. So for x-intercepts, you set the numerator equal to 0. Equal to 0. And then solve. And for y-intercepts, you do what? Set x equals 0. Also, I didn't add this with horizontal asymptotes, but if I were to find my range, like we did the domain, range is negative infinity to horizontal asymptote, union, horizontal asymptote to positive infinity. So those are just kind of added, but remember those are the rules for domain and range. All right, so if we look at number 1, what I like to do is I like to write out vertical asymptote, horizontal asymptote, x-intercept, and y-intercept. And I just kind of make 4 columns like this. And I solve for each one of those separately. So with my vertical asymptote, it says set denominator equal to 0 and solve. But you'll notice that the denominator has an x squared. So how many solutions am I going to have? 2. So if I say x squared plus 1 equals 0, then I say x squared equals negative 1. Then if I take the square root of x squared and the square root of negative 1, what kind of solutions do you get? Imaginary. If you get imaginary, then you would just say none. We don't graph imaginaries. Because you can't, exactly. You cannot graph imaginary, so we would say that there is none, there are no vertical asymptotes. Yeah, so if it comes out to an I, then we don't graph those, okay? For horizontal asymptote, I look at the degree. So I have nothing over 6 over x squared. So I have a degree of 0 over a degree of 2. So that would mean that it's bigger on the what? On the bottom. And if it's bigger on the bottom, then we say y equals 0. So I'm going to put a dashed line here at 0. Because we have 6 over x squared, bigger on the bottom, so y equals 0. For my x-intercept, I set the numerator equal to 0. And so my if I were to solve that, it would just be 6. So x equals 6. Or y equals 6.
So when should you change that where it says HA y equals 0?
Oh, wait, hold on. I was doing y-intercept. Sorry. For x-intercept, 6 equals 0. That doesn't make sense. So I would have no x-intercepts. And then for y-intercept, I would set x equal to 0. So you get y equals 6 over 0 plus 1, which would just be 6. And the reason why I don't have any x-intercepts is because my horizontal asymptote is at 0. So it's actually never going to touch 0. It'll never touch the x-axis. So it'll get really close, but it'll actually never touch the x-axis. So I have no x-intercepts, and I have a y-intercept at 0, 6. So if I have no vertical asymptote, then my domain would be what? You want to have any idea? If it doesn't stop at a vertical asymptote, that means it's going to keep on going. So negative infinity to positive infinity. And I want you to put this into your calculator. So I want you to try and graph it really quickly and see what it looks like. So when you put this function into your calculator, you wouldn't probably do this one without a calculator. This one is a little special. All right, so whenever you graph this in your calculator, so it would be from 0 to positive infinity because it never crosses, like I don't have anything down here on my graph. It doesn't actually touch 0. It starts at my horizontal asymptote and it goes.
I'm talking about the positive infinity part because it looks like it stops at.
Oh, at 6. At 6. My bad. It would stop at 6. That's my max. All right, so we have the 4 things that we are solving for. We have vertical asymptote, we have horizontal asymptote, we have x-intercept, and we have y-intercept. So for vertical asymptote, I set the denominator equal to 0. So x squared minus 9 equals 0. X squared equals 9. And so then I take the square root, x equals plus or minus 3 whenever I square root both of those. So I'm going to have 2 vertical asymptotes. I'm going to have one at negative 3 and I'm going to have one at positive 3. So I'm going to write x equals negative 3 and x equals positive 3. So I'm going to draw my vertical asymptotes. I have 2 of them. Anytime you have like an x squared on the bottom, you'll have 2 of them unless they're imaginary. Then my horizontal asymptote, I look at the degree. So I look at the top degree and the bottom degree. I have 2x squared over x squared. Are my degrees the same or are they different? They're the same, so they cross out, and I am just left with y equals 2 as my horizontal asymptote. So I'm going to put a dashed line at y equals 2. Then if I were to create my domain and range, my domain is now going to have 2 unions since I have 2 horizontal asymptotes. So it's going to look like negative infinity to negative 3, union, negative 3 to positive 3, union, 3 to positive infinity. So it's going to take a break at both of my vertical asymptotes. Okay, it's going to go from negative infinity, it's going to stop. Then it's going to go from negative 3 to positive 3, then it's going to stop. It's going to go from 3 to positive infinity. If you put this in your calculator, then you can see that on the graph. You can see that it has 2 asymptotes. Then my range is based off of my horizontal asymptote. It's going to go from negative infinity, and it's going to stop where? At 2, union, 2 to positive infinity. Then I have x-intercept and y-intercept. X-intercept is setting the numerator equal to 0, so 2x squared equals 0. Divide each side by 2. X squared equals 0. Square root x just equals 0. So I have an x-intercept at 0. And then my y-intercept is setting x equal to 0. So I say y equals 0 over 0 minus 9. 0 over negative 9 is just 0. So I have an intercept at 0. So I would put 0, 0, 0, 0. Now, if I wanted to graph this in my calculator, then I would see that the graph looks something like this. But if you wanted to do it without your calculator, then you could test points. However, like I said, I'm mainly just going to be grading this kind of stuff. So you would have your calculator if you were graphing it. I may just give you the equation and then have you solve for those 5 things without a calculator, but graphing it would be with your calculator. No, something like the last lesson you could graph without a calculator. So we're going to change the range because since this stops at 0 right here, since it stops at 0, the range would go from negative infinity to 0, and then it would go from 2 to positive infinity. So change this to 0, and then put a u, and then 2 to positive infinity. It's kind of ugly. I'm going to fix that. So negative infinity to 0, union, 2 to positive infinity. Okay, so slant asymptotes, we're going to talk about those. That is whenever your degree on the top is bigger than the degree on the bottom. It says that we have no horizontal asymptote, but we do have a slant asymptote. And so in order to find that, like it was in the example of number 1, there was no horizontal asymptote, but you did have slant asymptotes. And in order to find those, you divide the top by the bottom using synthetic or long division. We're only going to do synthetic division in this class. We're not going to do by long division. And the equation that you get is your slant asymptote. But really quickly, what I want you to write in is when you do synthetic division, ignore the remainder. So you're going to get a remainder when you do synthetic division. And we'll do an example here on the back. You're going to get a remainder, and it could be like 75 as your remainder. You're going to ignore that, and you're only going to use the number of the equation. Because when you do synthetic division, you're going to end up with a linear equation. We're only going to use the number. So I want you to write this in, and then this is going to make more sense whenever we do examples on the back. Okay, so I'm going to write out all the things that I'm solving for. So I'm going to put vertical asymptote, horizontal asymptote, x-intercept, y-intercept, and then if I think I will end up having a slope intercept, so I'm just going to put that over here, and we'll do that one last. So for vertical asymptote, I do what? Set the denominator equal to 0, so x minus 2 equals 0, x equals 2. So I'm going to put a dashed line here at 2. Horizontal asymptote, what do I do?
X squared is bigger than x.
So I look at x squared over x. And so since the top is bigger, then that means that I do not have one, so that would be none. The bottom is bigger, it's 0, but if the top is bigger, then it's none. which means I'm going to have a slant asymptote. So when you get no horizontal, that means you get a slant. And so what that means with the slant asymptote is that your graph is going to kind of go towards a diagonal. And we're going to put it in our calculator here in a minute to show that. So then my x-intercept, I set the numerator equal to 0. So I would say x squared plus 3x minus 4 equals 0. I'm going to have two solutions because it's squared. So that means that I need to factor this. So how could I factor?
Multiply -1 and 4.
4 and -1. So x plus 4, x minus 1. So I'm going to have an x-intercept at -4 and an x-intercept at a +1. So -4, 0, 1, 0. So I'm going to go ahead and plot those points at -4 and 1.
Wait, so if there was a quiz, would you want us to like put the x-intercepts in?
Yeah, ordered pairs. Put them in ordered pairs, please. And then my y-intercept, I'm going to set x equal to 0. So y equals 0 plus 0 minus 4 over 0 minus 2. So I end up getting 2. So my y-intercept is at 0, comma 2. So I'm going to put a dot there. Then I'm going to solve for my slant asymptote. So what that means is you're going to take your numerator and you're going to divide it by the denominator. You're going to do synthetic division. So when I'm doing synthetic division, what goes in that box on the left? Right here, I'm going to set that equal to 0. And so I get x equals 2, right? And so 2 goes in that box right here. No. Then I'm going to write the coefficients of the top. And remember, I don't skip any. So I have x squared, x, and just the number. So what numbers go across that top row? 1, 3, -4. Then I bring the 1 down. So when I bring the 1 down, 2 times 1, 2. Add across, 5. 2 times 5 is 10. And you get a +6. This is my remainder. I ignore it. Don't even worry about that. So we ignore the remainder. I know that's hard to do, but we just ignore it. So when I'm taking an x squared and then I'm subtracting a degree, what would this equation look like? It would be x equals 5. It wouldn't be x equals 5, it would be x plus 5, sorry. X plus 5. So y equals x plus 5. If I were to graph that, that is a linear equation. A linear equation that has a slope of 1 and it has a y-intercept of 5. So my slant asymptote looks like this. My slope will always be 1 because remember you bring the 1 down. And so it's going to be x plus 5. So if you put this in your calculator, I want you to put this in your calculator. You're going to see when you graph this that it looks kind of like that. So once you have it graphed on your calculator, if you zoomed out, you should have seen that there was something like a function that was at the top, kind of. So if you haven't zoomed out enough, remember that rational functions always have two parts to it, right? And one goes through, one is like above the asymptote, one is below or to the left and to the right. And so if I were to find my domain and range of this, my domain is going to be from -infinity to what? Where does it stop? At my vertical asymptote, which is 2, union 2 to +infinity. But my range is a little bit different. So my range is going to go from negative infinity, and then it's going to stop at this point right here. This is like the max, right? It hits that max, and then it takes a break for a little while. So in my calculator, how can I figure out what that y value is if that were to be considered a max? I trace it, okay? So you're going to go to menu, trace, graph, trace. Menu, trace, graph, trace. And I want you to find what the y value is of that max. So this ordered pair is at 2.101. That's what I got. Like something around that. That's okay. Okay, that's fine. If it's off by like a little decimal, that's okay. So 2.101 union. Then I'm going to find this minimum point right here. So since you have zoomed out, it's going to go ahead and start back up at that minimum, and it's going to go to positive infinity. And so how do I find that minimum? I have to analyze the graph, and I have to do the minimum point. So menu trace, graph trace. And we have said that the y value is 11.9. Is that what you said? 11.9. Is that what everybody else got? To positive infinity. You cannot do this without a calculator, so I want you to write that. Cannot do range without a calculator. So I don't want you to study this and say, is she going to put this on non-calculator? Cannot do without calculator. Miss Thornhill will not put this on a test without a calculator. I cannot do this without a calculator. I will say that again. Cannot do it without a calculator. All right, so I want you to try number 4. Okay, so let's go over this. We have vertical asymptote. So vertical asymptote, we are going to set the denominator equal to 0. So x squared minus 1 equals 0. X squared equals 1. So x equals what?
Negative 1 and 1.
Plus or minus 1, so negative 1 and positive 1. So x equals negative 1, x equals a positive 1. So I'm going to go ahead and put my dashed lines there. And my horizontal asymptote, I look at the degrees. So I have 3x squared over x squared. My degrees, are they different or are they the same? The same, so they cancel out and I just get 3. So y equals 3 is my horizontal asymptote. Like this. And my slant asymptote I will not have because you cannot have a horizontal asymptote and a slant at the same time. It's either one or the other. The only time you have a slant asymptote is if your degree is bigger on top. My x-intercept, I set the numerator equal to 0. And so 3x squared equals 0. So x equals 0. So I have 0, 0. Going to put a point there. My y-intercept, I set x equal to 0. And so I get 0 over 0 minus 1, which is also just 0. So that is for y-intercept.
For the essay, what do you mean by one or the other?
Like you're never going to have a horizontal and a slant at the same time. The only time you have a slant is if you don't have a horizontal asymptote, which is only when the degree is bigger on top. So then if you were to put this in your calculator and graph, you'll notice that your graph looks something like this. So it went, like it looked like a parabola in between the vertical asymptotes, and then it was on the outer edges, like that. So for domain is going to have 3 parts. So you're going to have 2 unions connecting them. So it's going to go from negative infinity and it's going to stop where? At negative 1. Then it's going to have a union. Then it's going to go from the in-between parts. So negative 1 to positive 1. And then a union. And then a positive 1 to positive infinity. So 1 to positive infinity. But for range, it's going to go from negative infinity, and then it's going to stop at this point right here. It's going to stop at 0. So my range is from negative infinity to 0. Then it's going to pick back up where? It's going to pick back up at 3, and it's going to go all the way to positive infinity. All right, so we have vertical asymptote, horizontal, x-intercept, y-intercept, and slant if we need to, which I think we'll need a slant asymptote in this one. So for vertical asymptote, I just said the denominator equal to 0. X plus 4 equals 0. X equals negative 4. So I'm going to draw a vertical asymptote at negative 4. Horizontal asymptote, I look at the degree on the top, the degree on the bottom. I have x squared over x. Are they the same or different? They're different. Top is larger, so that means that there is none. Because top is larger. So I have no ha. That means I have a saw. That means I have a slant asymptote. X-intercept. X-intercept, I set the numerator equal to 0. And so numerator equal to 0 means I'm going to have two answers. 2x minus 3 equals 0. If I were to factor that, what would that look like? My equation would be y equals x minus 6. 2, 3, 4, 5. So I put a y-intercept at negative 6, and then I draw my dashed line like that. So I would put x minus 6, y equals x minus 6. Then my domain and range, we are not done. My domain is going to go from, if I look at my picture, it looks something kind of like this. And then if you look on your calculator, you should zoom out. It looks kind of something like there's something down here. Not the best picture. No, I wouldn't make you probably graph this. I would just look for domain and range. So then for domain, negative infinity, it stops where? At negative 4, union, negative 4, positive infinity. The range, it's going to stop at this max, and then it's going to pick back up at this min. Okay? So it's going to go from negative infinity. If you found a max value at that peak, the y value for that was what? Did anyone find out in their calculator? Negative 19.16. Oh, that's fine. Yeah. It's going to be a maximum because it's like a hump. Yeah, so it's a max here. So it's a max at this point, and then right here it is a min. So you're going to find a local max and then a local min. So it stops at, I think the ordered pair in your calculator is negative 8.6, negative 19.2. So it stops at this negative 19.2. And then it picks back up here at this ordered pair. And so if you found the local min for that ordered pair, what did you end up getting? It's like 0.58, negative 0.83. And so it picks back up at this negative 0.83, and it goes to positive infinity. So find your local max and then your local min, and it would stop here at the max and then pick back up at the min.